Welcome to part 7 of our series of video tutorials focused on Boolean logic and logic gates. In this session 7, what we're going to look at is converting Boolean statements into logic circuits and then looking at the truth tables that they create. So, we've got a Boolean statement in front of us and we've got not A or B and C. So, let's see if we can construct that. Well, we've got not A, so we'll have a not gate. There we go. Not A or, so we need an OR gate. There we go. So we'll put an OR gate in. Let's move that out of the way. So we know one of the inputs goes to there. So we've got not A or B and C. So we need an AND gate, so we need an AND gate there, and we link that one up. Now we need an output for that, so we'll use our light bulb as we have previously. There we go. And of course we need our input switches, so there we go. There's one to the AND gate, or NOT gate rather, one to the input 1, one to input 2, and there we go. So if we switch all of our inputs on, well, there we go. So we've got all of our inputs on there, so that's fine because we've got a NOT gate and we've got an AND gate. As long as we've got one input on, then we're fine. So we can see that this statement, not A or B and C, translates to this logic circuit. So that's one way of building from one to the other. So let's have a quick look at the truth table for that. So here's the truth table. So here's the truth table. Notice the Boolean statement in the far right, or the fourth column, not A or B and C, and we've got the inputs in the first three columns, A, B and C. Notice in this truth table that I have not included the value of not A and the value of B and C as separate columns, because that's not standard practice. When you're practicing in this, then it's a good idea to do that to make sure that you get them all in place. But typically speaking, this is how the truth table would be written for this Boolean statement. Yep, this Boolean statement here. Okay, so let's have a look at another example. Well, the example we've got here is slightly more complex. So let's have a look at how that's working out. We've got in the parentheses not A and not B. Okay, and then outside the parentheses we've got or not C. So let's have a little look at this. Let's get some gates onto the screen. So not and not. So that can serve as our not A, not B. Okay, and we've got an AND gate there. Okay, so I will join those two together. Right, there we go. Yep. Or not C. So, well, we want a NOT gate and we want an OR gate. Now notice that in this example we've got one level further than previously. Let's just put our output for good practice and then put some switches in for our gates. There we go. There we go. Oh, didn't quite join that one up. Try that again. There we are. There we are. Okay, so not A and not B. There we are. So not A or NOT gate, two NOT gates feed into an AND gate, which then feeds into the OR gate, and the second arm, or the second input for that final OR gate, C, which is our bottom NOT gate there. Yeah, so notice that we've got three NOT gates feeding in, so we've gone 3 deep into our truth table. And I'll just turn all those on. There we go. Okay, and of course, if I switch all of them on, then the value will be off. Yes, so not 0, 0 produce 1 and 1. Well, that will produce 1 there. That will produce that one out of there. and then that will produce that. So if I switch that one and that one, there we go, we're back on again. Yep, and we're back on again. Okay, now so let's have a look at the truth table for that. There we are. So there's our truth table for not A and not B or not C. Yep, there we go. So thank you very much.